एटमॉस्फेरिक सर्कुलेशन एंड वेदर सिस्टम में दूसरा वीडियो ये है हमारा। इसमें हमने पहले डिस्कस किया था एटमॉस्फेरिक प्रेशर के बारे में। अभी नेक्स्ट टॉपिक हमारा आएगा वर्टिकल वेरिएशन ऑफ प्रेशर। सो आज इसको हम समझेंगे। यहाँ पे आप एक फोटो देख रहे हैं जिसमें एक पर्सन नीचे खड़ा है, वन पर्सन स्टैंडिंग ऑन द ग्राउंड एंड वन person standing on the top. Okay, so both are in different height. So when we are talking about vertical variation of pressure, then we are talking about height, altitude. So here one table given in NCERT. In that one, on sea level atmospheric pressure is 1013.25 millibar. And what is millibar? Millibar is the measurement unit of atmospheric pressure. Understand? And average temperature on sea level 15.2 degrees centigrade. So when we are going up, when we are going on the height or altitude, then pressure decreases, temperature also decreases. So here one rate is given. You can see here 10 meter height, 1 millibar pressure decreases. Understand? So when we are talking about 5 kilometer, then pressure will be there 40.48 and temperature will decrease. Temperature every 1 kilometer temperature decrease 6.5 degrees centigrade. This is called normal lapse of temperature. And here given this table, in this one on mean sea level, air pressure and temperature, then on the altitude of 1 kilometer pressure, then 5 kilometer, then pressure, then 10 kilometer, what is the pressure? Okay, so these are the data, and according to that temperature also decreases. So on 10 kilometer temperature will be minus 49.7 degree centigrade. Okay, this is data about temperature and atmospheric pressure. So here in this slide we are talking about how temperature or pressure varies when we are going on altitude. So when we are downside, we are feeling lot of pressure. So what is the reason of that one? You can see this diagram. Here one man standing on the ground and there are lot of bubbles. You can see here what are the bubbles on that person. On that person's head there are lot of gases, and density of gases near to the ground is much more. And when we are going on altitude, then density of gases decreases. So that's why we are feeling low pressure on altitude and high pressure downside on the ground. Okay, this is about vertical variation. And why it happening? So here given the vertical pressure gradient force is much larger than that of horizontal pressure gradient when we are talking about one area having low pressure, one area having high pressure on the ground. So wind will wind will blow from high pressure to low pressure always. But vertical pressure is much more than horizontal pressure, but we are not feeling more. Why? What is the reason about that? Here given. Okay, so the vertical pressure gradient force is much larger than that of the horizontal pressure gradient, but it is generally balanced by a nearly equal but opposite gravitational force. Hence, so we do not experience strong upward winds. So winds here low pressure, here high pressure. So wind will blow from down to up. So we are not feeling such kind of winds, we are feeling on horizontal ground. So what is the reason about that? Such kind of winds balanced by gravitational force. So this is about vertical variation of pressure. Thank you.